So we did limits from graphs. That's where you kind of just look at it and go, hey, what is being approached? It doesn't matter if there's a hole there, it's just behavior. We did the limits to positive and negative infinity. That's your end behaviors where you look at who's in charge here. We did the piecewise functions where you make a decision, which piece of the function am I going to plug into? If you're not sure, pick one and plug in. And today we're going to do the limits analytically. Analytically means you don't have any of those supports. You don't have a graph to look at. It's just you and the function. And you have to figure out what's going on. So there's several different ways to approach these. So I'm going to teach it like, here's this method, here's this method, here's this method. So limits analytically, which means you just have a problem and you got to work it out. But what's important to remember, if you cover up the limit part, they're just algebra problems. Do you know what I'm saying? Like the limit is what makes it calculus. Otherwise, they're just algebra problems. So that's your pep talk for that. First method is that you plug in the value. You always want to do that first. That's why I'm covering this one first. Because if you can plug in the number and it just flat out works, that's your answer. Because I will sometimes have people be working on a problem. And they'll be like, I was working on this for 10 minutes and I can't figure it out. And I'm like, well, did you plug in one? And they're like, oh. So, always try that first. So let's do a couple of these. I know we're doing like real college today. You're going to have to actually write the problem. Yeah, like in real college, you're going to need like to bring paper every class and create your notes from scratch. I guess other than math, though, you'll be able to like type your notes, like use a laptop. Math, you're going to have to hand write though, because of all the symbols. So its limit as x goes to 5 for this function. The first thing you're going to do is plug in 5. So let's see what happens when we plug in 5. Y'all ready? 5 minus 1. Very good. 5 squared, 25 plus 2, 4/27 is your answer. Bless you. And so you always want to try this first, because if it works, then it saves you a lot of time. We'll just do one more of those because I don't really feel like we need to try like a ton of that. I'm going to throw one with an ln here though, so we can review our natural logarithm. Limit as x goes to 1 of ln of x plus 5. Do you remember Quizlet with your logarithms? You just did drill and practice. So you need to know what ln of 1 is. What is ln of 1? If you've all forgotten, I will tell you, but let's see if anyone remembers it. Oh, no, you're thinking of a base 10. This is base e. It's like this. Well, e to the 1 is 2, but that's well remembered. It's e to what power would give you 1? What exponent gives you 1? 0. Good. So this part is 0 plus 5 is 5. 0 plus 5 is 5. Any log of 1 is going to be 0 because anything to the 0 power gives you 1. But the whole takeaway there is you want to plug in the number. That's always your first approach. What? Oh, limit as x goes to 2. Then you would have ln of 2 plus 5. I don't know what ln of 2 is without a calculator. The only one I know is ln of 1 is 0. Okay, if you get, that's actually a really good question. Sorry, I didn't understand the question at first, but that's a really good question. If you get like ln of 7, you leave it ln of 7. Do you get what I'm saying? It's kind of like square root of 17 is just square root of 17. Without a calculator, you just leave it alone. All right, second method. If you get a value over 0, like 2 over 0 or 7 over 0 or 50 million over 0, what that means is that means there is an asymptote. It means there's an asymptote in your graph. If you get something divided by 0, it means you have an asymptote. So if it is one-sided, you can get an answer. So if it's one-sided, you're going to check the denominator, only the denominator, And your answer will either be negative infinity or positive infinity. If you have a vertical asymptote, it's either going to go up or go down. So you have a 50-50 shot of getting it. But it only works if it's one-sided. If it's not one-sided, you can't get an answer, and so it's automatically going to be what? D, and it does not exist. If you have an asymptote and it isn't sided, the two arrows are never going to meet up, so you get does not exist. So if it's not one-sided, it does not exist. Okay, so we're going to try a few of these. All right, so you're going to start like I told you up here and plug in the value. It says 2 from the left. You're still going to plug in 2. 2 is the number. Do you get what I'm saying? Because people are like, well, it's 2 from the left. I don't care. 2. You're going to plug in 2 and see what happens. All right, you ready? 2 plus 7. Very good. 2 minus 2. Oh my gosh, it came out to, that means there's an asymptote. Is it sided? Yes. So that means we can get an answer. It's either up or down. We're just checking our sign. Now, you only have to check the denominator. People are like, well, what about the numerator? Hey, kiddos, the numerator came out to 9. 9's a positive number. I don't need to check 9. I know that 9 is positive. Okay, you can put a little plus if you want, but 9 is a positive number. We just need to check the denominator. Now, here's where you pick a number to the left of 2. So can you give me a number to the left of 1? Very good. 1 minus 2 is negative. So do you see how we got a positive over a negative? So our answer is negative infinity. At that point, it's either going up or down, because if you have a vertical asymptote, it has to go one or the other. If you were like, hey, I didn't quite get that, that's fine. I'm going to do a couple more of these because you have to do a few for it to like settle in. I'm not trying to torture you, but I'm going to do a couple of each of these so you can see how it works out. All right, so do you see how it says 7 from the left? But you're still going to plug in 7. 7 is the number, okay? 7 minus 10. Negative 3, good. 7 minus 7, 0. Oh my gosh, it's a number over 0. That means there's an asymptote. Is it sided? That means we can get an answer. We're just going to check the sign. Negative 3, I don't have to check. That's negative, obviously. You only have to check the denominator. Now it's 7 from the left. Can you give me a number to the left of 7? Very good, 6. 6 minus 7 is negative 1, which is negative. Oh, why is it positive infinity? Negatives cancel. Very good. All right, we'll just try one more of these because I've finally gotten your attention. I woke everybody up here. So 10 is the number. We're going to just plug in 10. You ready? 2 times 10. 20. Good. On the denominator, 10 minus 10. 0. Oh my gosh. It came out to a number over 0. That means there's an asymptote. Is it sided? No. So what does that mean? Does not exist. If it isn't sided, you can't get an answer.
I don't know if it's sided.
It'll have a little plus or a minus with it. See how this one doesn't have a plus or a minus? That means the two sides have to meet up, and if there's an asymptote, they can never meet up, so it does not exist. Okay, third method. If you get 0 over 0, that means there is a hole. We'll talk more about this if you're going on to calculus, but the vocabulary word for that is called indeterminate. That's called indeterminate. It means that there's a hole. So if you get a value over 0, it means an asymptote. It's either going to go up or down. If you get 0 over 0, that means that there is a hole. You have to use algebra to cancel out. Do you remember how when you have something that cancels out, that's where the hole is? Okay, once you get something to cancel out, then you're good and you can just plug in whatever the number is. If you look back at the notes from the very first limits lesson that we did, that was the very first example that I did, was one of these, okay? Now, these are the ones that everybody likes the least because you have to do algebra and that means like work, like there's actual steps to them, but you'll be okay. Now, I'm just going to talk you through this. I won't make you write it, but watch and listen. If you plug in -1, hey guys, -1 squared, good, 1. -5 times -1 would be +5. So 1 plus 5, 6, minus 6, 0. And then down here, -1 squared is 1 and 1 minus 1. You always want to check that because here's what happens. People start trying to tear these apart with all kinds of algebra and they fill pages and pages with work and work and work and then find out that they could have just plugged in the number and they get very angry. Okay, so always try to plug it in for, it's a little funny, but I do feel bad when that happens. Okay, but anyway, it didn't work. Now, when you go to the next step, you still have to write limit. If you leave that off, it's no longer calculus, it's just algebra. Also, and I've seen this happen a lot, if you don't write limit as x goes to -1, you will forget to plug in the -1 at the end. That happens all the time. And then you won't get an answer. You'll forget, right? But what we're going to do is factor these. So draw your 2 blank parentheses. Welcome back to Algebra 2. Actually, you do this kind of factoring in Algebra 1 as well. X squared would split x times x. How would you split up 6? Oh, is this one going to be the 3 and 2 or the 1 and the 6? It comes down to the symbols. 6 always messes me up. I think it might be the 1 and the 6 because we need it to be negative. Yeah, actually, it's going to have to be the 1 and the 6. 2 and 3 and 1 and 6 always messes me up, messes everybody up. All right, to get a -5, you would need what symbols? Good, perfect. -6, +1. And then down here, that's going to split again. 1 always kind of messes everybody up too. What's your like split for 1? Like, how is 1 going to split? No, good, x plus 1, x minus 1. And oh my gosh, does something cancel out? It does. Now, again, people will stop there. And I'm like, you were so close. This is why you need to write limit. You have to then plug in the -1 to this part that's left to get the actual answer. So let's take -1 and plug it in. -1 minus 6, -7. Down here, -1 minus 1, -2, negatives cancel, 7/2. We'll do 2 more of these. These ones have the most work to them. Bless you. And yes, that is an H, not an X. You'll be okay. It's just a different letter of the alphabet. 4x. Yeah, that says 4x plus h squared and then minus 4x squared over h. Now, as a heads up, there's an x in the problem, which means there's going to be an x in your answer. That always bothers everybody. They're like, there's an x in the answer. I'm like, it's okay. There was 1 in the problem, so there's going to be 1 in the answer. All right. Now, you still want to try and plug in 0. You ready? I'm not going to do a break because I kind of like just want to finish. All right. We're going to push through. All right. If you plug in 0 for h, come with me here. 4x plus 0 is 4x. So you have 4x squared minus 4x squared, which would be 0. And then h is also 0. So it's 0 over 0. We know we need to do some algebra. So bring the limit with you. Again, without that, it's not calculus. And we're going to have to multiply out this first part. You guys were really good at this year, so let me see if you remember it. When you have anything squared, it means you need to write it twice. Okay, I'm just going to write it right above here to save myself some room. I'm just going to write it twice right there. Or if you can keep it in your imagination, you don't have to write it. If you're capable of doing it in your head, some people are, that's cool too. As long as you get the right answer, I don't really care. All right, we're going to distribute this all together. You ready? 4x times 4x. 16x squared. Good, perfect. Now the outsides will give you 4xh. The insides will give you 4xh. So together, 8xh. And then h times h squared. Everybody always hates the algebra because algebra means work. Algebra means steps and like having to write stuff. All right, minus. Now this is not like, I mean, I guess you could write it twice if you want to, like the 4x squared means this. I guess if that helps you, you could do that. But 4x times 4x is 16x squared. And then the whole thing is over h. Okay, we did the hard part. Now you want to look for stuff that goes away. So do you see any terms that will cancel? Good, the 16x squareds are gone. And we've got one more step where we're going to have to write limit. I'm sorry, but kind of not. You'll be all right. Out of the terms that are left, do you see how they both have an h in them? See how this has an h and that has an h? We're going to factor out an h, its greatest common factor. What's left when you divide out the h? Good, 8x. Oh my gosh, you guys are awesome. Plus h over h. And you're probably like, why on earth did we do that? Now, yes, perfect. Oh my gosh, you guys are awesome. Once it cancels, then you can just plug in your value. So if h is 0, what are you left with? 8x. And again, that bothers everybody. They're like, there's an x in the answer. And I'm like, well, there was an x in the problem. So that makes sense. Okay. We're going to do one more of those because they're the harder ones. Okay. You'll be okay. And I'm going to just keep on going because I think you guys will be fun. We plugged in 0 for h, and so the only thing left was the 8x. I kind of like the ones with square roots in them. There's one step that involves a little bit of writing, and then the problem just sort of like disintegrates. Everything kind of cancels out and goes away. So there's like one step that's kind of a lot, and then after that, it sort of just all falls apart. Now you always start by plugging in the number. If you find out you could have just plugged in the number, you're going to be upset if you did a lot of work. All right, you ready? 4 plus 5. 9. Square root of 9, 3, minus 3, 0, and then 4 minus 4, 0. Okay, here's what you do when there is a square root. You multiply by the conjugate. We've done conjugates before. Do you see how it's root of stuff minus 3? It's going to be root of stuff plus 3. And you have to do it on the numerator and denominator. So that's the one step where you kind of have to write a little bit. But anyone can write the same thing twice. That's my pep talk. Just write it twice and you'll be fine. Just instead of a minus 3, it's a plus 3. The reason we do that is so stuff will cancel and blah, blah, blah. You'll be okay. So you still have to write your limit. If you don't write that, again, it's not calculus, it's algebra. And you're going to forget to plug in 4 at the end. I see that all the time. People will do the problem beautifully and then not plug in 4. So when we multiply these together, just watch. Square root of x plus 5 times square root of x plus 5 will just be x plus 5. The roots cancel, and that was the whole point. Did you guys go with me there? Yeah. Roots cancel. Okay. Now the outsides will give you a plus 3 square root of blah, blah, blah. The insides will give you a minus 3 square root of blah, blah, blah. So what happens to those? Oh my gosh, they're gone too. And then do negative 3 times 3, which will be negative 9. Now this also does get people. What should you do with the denominator? Literally nothing. Just recopy it. What should you do? Nothing. Now I would give this a hug, like put a hug around the x minus 4, but literally just recopy it. If you try to multiply that all together, you will get a gigantic mess. It will be a horrible disaster. And hopefully you should be like, hey, wait a second, I goofed here because I'm getting complete garbage, all right? But I want you to look through there because we're actually going to be able to just write the answer at this point. Do you see what's going to happen? What is our numerator? Oh my gosh, x plus 5 minus 9, that is x minus 4. These cancel. Once you get something to cancel, you just plug in your number. Now, what's still in the numerator since it's good? 1, and if you plug in 4 down here, 4 plus 5, 9, square root of 9, 3, and then 3 plus 3 is 6, so 1, 6. So there is that one step where you have to write this twice, but after that, you kind of just write the answer because everything cancels out. So let me recap real quick. There's one last method. Plug in the value, always do that first. If you have an asymptote, you're going to check the denominator. It's either up or down. You have a 50-50 shot. If you get 0 over 0, that's like womp womp. You have to do work. All right, 0, 0 is the one where you have to do work to get something to cancel. Last method. If all of that fails, if you cannot get any of that to work for you, you're going to draw a graph. And then you can just look at it and go, hey, where do the two pieces meet up? If none of that works, draw a graph. It's like your last ditch effort, like your Hail Mary, nothing else worked. Last resort, draw a graph. Okay. You plug in 4. Well, you're gonna have to draw a graph.
I see. Yeah.
Why don't you just watch and then decide how you can write it? Okay, these don't take a long time. You just draw a graph and then look at it. Actually, I'm gonna make 9 and 10 be based on the same graph. So we can just draw it once. Sorry, that's an M. Yeah, it's not an absolute value. When it's that double bracket or like bolded, do you remember what kind of graph that is? We did cover them and you guys actually did really great with it. It was back in unit 2. Do you remember when we did the stretches? And oh my gosh, do you remember me with my slinky up here at the beginning of the year? Well, this did move up 1, but what parent function is this? Remember parent function? The stair one. It's called greatest integer, but if you remember it's stairs, then we're good. Okay, so we're going to draw a picture. Do you remember when we stretched the stairs? Do you remember when the stairs were wider? And do you remember when the stairs were more units apart from each other? Now it's your staircase, but I moved it up 1 just to, you know, throw a transformation in there. So instead of starting at the origin, you're going to start up 1, put a point there, and that's where your first step is. And then you can just draw in more steps from there. And that's good enough. You don't need to draw like a bazillion of them. So now all we need to do is look at it. So can you guys look with me? Because I don't have a better explanation than look, here it is. This is 2 from the left. Okay, do you guys see how here's 2? Right here, it's a jump discontinuity. If you go to 2 from the left, like you're going this way, I know there's a hole there, but it doesn't matter. What y value are we on? 2, so that answers 2. And then if you go to 2 from the right, you're going this way, What y value is that? 3. If I asked you for 2 overall, why would it be does not exist? Yep, they don't connect. Perfect. All right, one more here. Yes. I just did a few from each like method, like each category. But draw a graph is like your last ditch effort. Like nothing else works. I couldn't do any algebra. I couldn't figure it out. Just draw a graph. Now to recap, listen. ln of 1 is 0. We did that on the other side of the paper. Remember that? ln of 1 is 0. But if you try to plug in -2, you get ln of 0, which is not a thing. And the reason why is there's an asymptote. So you'd want to draw a picture. Your ln, do you remember the exponential being a swoop? Look at this. Okay, it's a sideways swoop. And this graph moved what direction to? Remember, it's kind of backwards. Moved left 2. So you're going to go left 2, dot that in, and it looks like that. And after I write this answer, don't stop listening to me because I'm going to recap this question. If you go to -2 from the right, which it's good it's from the right, why can't you approach -2 from the left? There's nothing there, okay? Now, if you go to -2 from the right, where is this arrow headed? Down, so we're going to put -infinity. And you can put that because it's sided. Here's the takeaway. If you get a limit that involves an ln and you can't figure it out, are you listening?
Yes.
And you just have to guess -infinity. It's the only interesting part of the graph. It's a pretty boring graph, right? So if you get an ln and you can't figure it out, you just have to guess -infinity because that's probably the answer. Okay?